Hello, everybody. My name is Gauthier Falconet. I'm the Vice President of the Car Connectivity Consortium, and I'm here to present you both the activities of the Car Connectivity Consortium, who we are, what we do, and the MirrorLink technology, which is a technology that we develop inside this consortium that is looking to bring apps in the car. So, some overview of the agenda. I will start with providing you the landscape for smartphone integration into cars. So what are the questions that we should ask ourselves when we bring application in the cars? Then I will present you the Car Connectivity Consortium, what we do, how we work, and especially the MirrorLink technology, which is a technology that we develop to bring apps in cars. During this presentation, I will also present you the certification process we are putting in place to bring these applications and certify them, and in the end, the topic of applications. So some insights. First, connectivity in cars is something that is getting more and more a need. Connectivity to infrastructure, connectivity to other cars, the car-to-car product, connectivity to other machines, to the cloud, and connectivity through e-calls. So consumers, they want to be connected everywhere, and this is another thing. They have their apps, they want to have their apps everywhere. They want to be able to be connected to other friends. They want that their life, when they come in the car, is not stopped. And as their life is being online, when they're driving, they feel like something is missing. And another insight we have is currently there are plenty of connectivity solutions for smartphones. And these solutions, they are standardized. If we are thinking of USB, Wi-Fi, NFC, all these solutions of connectivity have their place where they can be standardized. If we are thinking of the way that currently we bring apps in the car, here's an extract of the portfolio of the applications of the program, started by the car makers to be able to bring application in cars. So we see that every car maker, because they are not generic, every car maker is having its own program. So if an app developer is thinking, oh, I would like to develop an app in car, I have a very good use case, and this would be very interesting, then in order to achieve that, he has to contact every single one of these. He has to adapt the HMI of his application to each and every one of these. We see that the HMI is very different, whether this is only logo, but each HMI, it's the way it behaves. Is it hosted on the smartphone? Is there a piece on the smartphone on the car? All this is completely different if we are talking to on any one of these applications. So, other concerns? Safety? Of course, we all want to have fewer distracted drivers. Driver distraction is really a topic that is hot and that is complex. And in cars specifically, it's a very unique environment. It requires to have the attention of the driver not on the application compared to what you are doing on smartphone, but the attention on the road. So the UX design has to be really done in such a way that it will minimize this attention while providing good content. And this leads to applications that are to be designed in such a way that they can be used in the car. And in addition to that, different governments has established guidelines that are very complex because they are targeting the car industry that have specialists to integrate these guidelines while they are building head units. And they are not useful for an application developer because they are too complex. They require too much effort to bring the app in the car. So it leverages down the value. Also, smartphones are evolving very fast. The technology of transmission moved to 2G, 3G, 3.5G, LTE. I'm quite sure that within a few years, it will be a new technology that will be twice or 10 times faster. And this is something that is very challenging when we are thinking of the use case, because the smartphone will evolve. The technology inside the smartphone will evolve. And there will be new applications. Every picoseconds, there is a new application available on the App Store. And in order to follow that, and these new services that are created in the car, we need to think something different. And we need to bridge smartphones that are moving very fast, applications that are changing very, very fast, and car industry that is having a more complex, deep development cycle. And so we could think that compared to this proprietary solution, car industry and handset manufacturer came together and say, this is not working. And we need to work together to develop a technology that will be something different. And so this is where the Car Connectivity Consortium came. It's a consortium that is really targeting the development of a smartphone car solution. What's very important is we are open to any company that is willing to join us, that is interested in the use case and the technology we are building. Either they are really app developers, use case oriented, or they are device maker and they're willing to bring apps in cars. The solution, the MirrorLink solution and the solution that we are developing inside a consortium are not owned by a single company. And this is something very different. So as soon as an app developer develops an app that is MirrorLink compliant, he will expect to see it working in all devices that are MirrorLink compliant. And this is what we are offering. And we are OS agnostic, which means that we are not tightened to an OS on the smartphone side, on the head unit side, and this is very important. The app developer don't want to change the app. It's working, it's here. They might be ready to adapt this application, and so the MirrorLink solution is agnostic of the OS, and this is very important. Also, we are providing device certification to be sure that the devices are going to work correctly together, both the smartphone and the head unit. But we are also providing certification of application so that everyone in the chain, including the end user, is sure that his application has been designed in such a way that it will integrate correctly in the car, and especially taking into account these driver distraction rules. So the Car Connectivity Consortium is really about bringing the car makers, the handset makers, the head unit industry together with the app developers to work on fantastic products. We are established in February 2011, so 2 years from now. We have rapid growth. We are now 85 members. And what's most interesting here is that we represent 80% of the global market share in automotive, which is huge, and 70% of the smartphone industry. So compared to the other technology, this is a very big difference. And if you are an app developer, this should be one thing you should look very carefully. And so, as I told you, MirrorLink is the open standard for smartphone car integration, and this technology, the MirrorLink technology, is developed by the CCC. So here are some of our members. You see all the big players are here, car makers. I'm not going to, you have eyes. Phone vendors, there are fewer, so because the market is like this. Nokia, HTC, Samsung, Panasonic, LG. We have RIM that has joined us. Everybody that matters in both the auto industry and the phone industry are there. We also have some tier ones. We have some app developers, navigation app developers. Everybody that should be here is here, and this is what's important. And we are all together to make the apps in car possible. So what's the MirrorLink concept? Actually, you have your phone in your pocket. You have some apps inside. You know that these apps has been certified. You don't know how, but you know because it's advertised. And when you connect your phone to your car, it's a copy of the image of your phone that is sent to the car. And this enables the apps as it is to be copied in the car. So this enables app developers to continue building their apps for the smartphone, but when the application is just, the smartphone application is just MirrorLink enabled, it will enable that when the phone is connected to the car, that the app is advertised and being able to be replicated, mirrored in the car. In addition to that, it enables to use the car controls to control the applications. So as we see, when we are connected, it's a replication of the screen that is on the head unit. It's a pixel per pixel replication. The calculation, the program, is hosted in the smartphone. But the user then don't have to use the smartphone. He will just use the car screen, dashboard, to manipulate the applications. So it includes touchscreen events that are sent back to the application. And this is really the big difference. There is no completely re-encoding. There is no HMI completely redesigned. This is really the difference. Where are we right now? So in 2011, we had the first aftermarket product on the car side. Alpine, Sony, and GVC Kenwood develop aftermarket solution for the car usage. We also have the Toyota IQ that were the first to announce their car enabled with MirrorLink together with Panasonic, a head unit, first head unit in IQ. And we have Nokia on the smartphone side that is supporting MirrorLink in Symbian Bell and MeeGo. And for the Android platform, we have Samsung that has the MirrorLink enabled in his Galaxy S3. We also have Panasonic and Sony that are producing currently products with MirrorLink enabled. So here, if you look, in addition to these devices that are available to the market, we also have 261 products that are potentially MirrorLink enabled because they are certified. They have been certified, as I said before, of the certification process. And this includes, this is 11 unique handsets because we also certify variants. So 11 unique handsets and 17 head units are certified against MirrorLink and that currently have MirrorLink inside, but they are not in production. And so they are waiting for the certification for the 1.1, the evolution of MirrorLink that includes additional features, which includes the one that I will present you today. And when this will be done, and this should happen half of this year, it will be line fit. So products coming natively, cars sold, first mount with MirrorLink, smartphones, including MirrorLink being sold. And in 2015, we foresee volumes of MirrorLink products devices. So if you focus more on the business context, so we do not differentiate in middleware or connectivity. We are connectivity agnostics. Our solution is based on IP, so it can run in USB, in Wi-Fi, and we don't require some specific OS vendor middleware. The only thing we require is to have these interaction between the apps and the smartphone, these APIs that will be used to know that the application, that will be used for the application to know that it's executed in a MirrorLink context, in a car context, and to adapt its HMI. We are, as I said before, we don't care about the user interface. If you have innovation in the user interface, you are we fully support this new interface that will come, and we don't have hand in this. As soon as they fulfill the driver distraction, it's 100% great. And we don't care also on which operating system you run with. So MirrorLink, it's about allowing application to provide differentiation, as I said before. We don't have some spatial infrastructure to be taken care of. All this is handled by the CCC, and all this is transparent for the end user. And this will maximize ROI for everyone in the value chain, both application, devices. This is a very big difference. And it's an open, generic approach to address the usage and also to address the driver distraction issue when you are building an app for a car. And we are not conflicting with current car implementation in embedded automotive solutions. We are compliant with them, and it's just software evolution of these head units to support these additional applications. And we are building the full architecture to enable app developers to do so. So if you are an app developer, if you are a device maker, or if you are just thinking of use case you would like to see coming between a smartphone and a car, this is the place to be, and contact us. But again, if I design for an application, I want to get full attention of the user all the time, because if he's bored, he will switch. And this full attention is not designed to be used in car. In car, you want to provide a service with the less driver distraction possible. So how to do this? So as you see here, in the phone mode, the text is very small, pictures are small. You can barely use it while driving. But the idea is really to have this switch between an HMI that has been to be used in the smartphone to an HMI that has been thought to be used in the car. And for this, we are providing UI guidelines that are inspired and that are taking into account. It's a digested version of the guidelines available in Europe from ESOP and from the American market and for the American regulator and the Japan regulator. It's a digest version of this. It's really targeted to extract the relevant information for app developers to develop apps in car that are the less driver distractive possible. And also we provide the mechanisms to have the application certification working. So what's coming? Applications. We want to remove distraction. We want to have a fewer distracted user in the street. And all these reasons, I already explained them. But our response to this specific UX design, this application that should be created for the in-car use, we address it in two ways. The first one is to get the knowledge of the application that it's in the car and not in the hand of the consumer, and that it's rendered in the car and used in the car. And this is done through APIs that we are providing to the developers. And the second part is the possibility for an app developer to certify its apps. And in addition to that, this process and this certification process is meant to be the most transparent possible for the app developers. So the process I'm going to show you, we are targeting first half of 2013, so it's right now, for stage delivery of the application certification system on the market. So regarding certification of applications, so you must understand that the application can be in 3 states. The first one is standard application. Application on the smartphone, like Angry Birds, doesn't have the knowledge of that it's even one time executed in the car. This application does not appear on the head unit. It's not meant to it. And through the MirrorLink interface, it's only when you get base certified, it certifies that you have the API in order to switch from the phone mode to the car mode. It's only when you have this base certified that you can run in the car while standing, while parking. And well, you see all the elements. But when, in addition to that, when you are base certified, so you are able to be rendered on the car, if your phone and your car is MirrorLink enabled, your application will be able to be rendered in car. But if you want to, say, now I fulfill the guidelines that you're providing in my apps, and I want to move in car while driving to the driver. And so this is where comes the Drive certified application, MirrorLink Drive certified application. So it's all the above plus the fact that the application can be used from a smartphone while driving. And this can be achieved through the fact that you have been certified because your application has been to an independent testing lab that has validated that the job you've done to make it available in the car is fulfilling these guidelines. So the application developers stand here. So for them, it's not a very big change from getting the apps available to the end user. So they use the general app store they have, generic one. So the phone gets available, so the apps get available in the phone. And it comes to us and say, I would like to apply for Drive certification. And I have now fulfilled the guidelines that you are providing me because they are public. And I also have the APIs implemented. And we say, now then, we register you, but please go testing your app in order to check that you have fulfilled these requirements. No problem. The app is approved. The test results are shown to this system. And here stops the interaction with the developer. The job of the developer is done. The application is certified. And now, when the apps will be downloaded on the smartphone using the common way of application stores, it will be listed in MirrorLink client. As soon as the app is certified on the client, so the head unit, and the server of the smartphone, as soon as the application is certified, it will be able to show on every head unit. And so when we see this, we see that for the developer, they just have to go to this test lab to get the apps approved. And for the end user, they just have to download the apps, which is something they already do. And if the apps is MirrorLink certified, it will appear on the head unit. And with the UI that has been designed, especially by the app developer. So a summary. So we are a global cooperation forum. So a forum of cooperation to develop smartphone-based connected car solutions. As I said before, we are open to any company that is interested in this project and to provide feedback, to provide new applications, to provide new devices. This is something we are really looking forward to. And again, this solution is a solution that is owned by the members. So owned by all the members you see before. They own the solution, they can implement this. And if you join us, you will be able to do so too. And this is really the key elements. The MirrorLink is not only a connectivity solution. It's an open industry standard and open industry standard. All the words matter for smartphone, car integration, and to bring the phone apps in the car in the good way. And we are also providing a common application development guidelines, as I told before, both the guidelines and the API for app developers. And we are providing transparency through the certification process we are putting in place, as I showed before. And we are providing apps that will be MirrorLink certified. So if you are interested in knowing more on the technical side, what it implies to build a device that is MirrorLink compliant, I fully encourage you to have a look in this link and to download our specification. It will show you the 1.0 version, which is the one that products are already built on the market. If you want to know what's coming right now, and I encourage you to contact us, and you will show the latest version, which is the 1.1 for new devices. So The Car Connectivity Consortium, we are meeting all together 3 times a year, where we have different working groups. The first one is technical working group. It's really on the technical side how to implement the solution we want, so MirrorLink, but also new use cases that will be brought by the user experience working group. So this is the place where people can provide feedback, new use cases, and say, okay, I have these new use cases between phone and cars, and I would like to create this. And this is where we take into account these elements. And the certification working group also is in charge of all the certification process, all the definition of the management of these certificates, so that it's completely, or it's as transparent as it can be for the end user. And we also have test events 3 times a year for IOP between devices. And so this is really the place where we check that the smartphone and the devices are, and the car, sorry. The smartphone and, I will not make it. The smartphone and the car head unit will work together. And technical workshops to work on technical details. So if you want more information, I invite you to see our website, mirrorlink.com. And if you have questions at carconnectivity.org, feel free to send any questions. If you would like to provide feedback on elements we are developing, if you are willing to join, if you are willing to build products, to build apps, there is one address. It's question@carconnectivity.org.
Okay, so I would like to build on a bit on top of what Gauthier was explaining, and I would like to give it a bit more touch from a device manufacturer perspective, to give you some background where we see value for the mobile ecosystem, and also as I'm sharing the technical workgroup, I can hardly resist also to go at least one level, a bit more detail to explain a bit more how the technology works. But don't worry, it's not a deep dive. I will really just scratch a bit on the technical level. So what I'm looking into is for this next half hour a bit on the mobile conversions within the vehicle, and see how smartphones and infotainment systems are working together from a history perspective. Go a bit into the technology by looking into what are the technology enablers which we need in order to run MirrorLink. Speak a bit about interoperability, and then focus a bit on what the relevance from a mobile industry perspective, from a device manufacturer perspective, we have with MirrorLink. We have a panel at the end, but please don't see the panel as just being the panel is speaking to each other. It's really meant for you the opportunity to ask questions, address it to the panel, address it to myself, and use it as an interactive discussion about MirrorLink, about the CCC, and about this topic. So one of the interesting thing, if you look at the mobile conversions of smartphones into the vehicle, is actually both of them are more or less the same age. Both technologies, communication technology in the automotive, is about 130 years old. They grew up most of the times independent from each other. They didn't know each other. And only recently they actually started recognizing, oh, there is this other guy. I've been growing up with him for 110 years, and now I actually see him. So that's an interesting thing, actually, that both of them are more or less the same age. The automotive side, this more or less was always about radio broadcasting for a long time. So you've seen that the first radios then, I think that at least the one picture I have there is supposed to be the first mass market radio. I guess this one. Actually, I have a hard time to find out what the radio is. And it was first started with broadcast, and then later on you recognize that though the user actually don't want to listen always to what's presented, he wants also to bring his own content. So there was a change coming into the infotainment part of the car, where people wanted to bring something into the car, to personalize. And the personalization was done by bringing their own music, bringing their own media. So by cassettes, by CDs, and so forth. In the recent years, actually, there was a tremendous change when smartphones mainly was introduced to the mass market, 5-6 years ago. And the main thing by the introduction was that the concept of this app. And that was so successful that now everybody speaks about applications. There is this application for everything. And it's now very difficult for us to actually get rid of those devices because we have everything on it. We have application for everything. And at least if I forget the phone at home, I go back. If I forget my keys, I don't go back. I just say, okay, my wife will take care of that. I find a way. But if I lose my phone or if I forgot it, I will take care of that, getting it back because of everything which on it, which I really, really need to. And that is where we see that this has been coming quite a long time as well. So it was mentioned, 120 years old, cars 120 years old, but now the things are coming together because we heavily rely on this as we're relying on the car for our transportation and mobility needs. We rely on the phones to stay connected. And as we spend so much time in the car on a daily basis, we need to have access to what the phone is providing us. So meaning we really need to consider how we have access to the phone and to the phone's content, to the phone's application, while we are on the road, while we are mobile within the car. So that's something what car manufacturers then took on. Say, okay, yeah, no, we need to embrace the concept of apps and also start thinking on how we access, how we provide access to applications for the user. Of course, the first app, which is actually pretty old also in automotive perspective, is navigation. So you have navigation system for quite a long time. But that is more or less the only application which was provided besides the sort of entertainment part. With the smartphone coming in, you recognize now that car manufacturers are working on different ways to interact with the phone. You have standard ways like USB, like Bluetooth, so you can set up phone calls. You connect your audio system via Bluetooth to the phone to take phone calls. You can stream, have access to media on the phone using Bluetooth profiles or USB profiles. But the phone offers more than just media and phone call. There is social applications, location-based services, all type of personal information which is difficult to classify and difficult to interact with. So therefore, you have seen now different approaches where each of the car manufacturers have a different way to interact to what is available on the phone. So from a smartphone manufacturer perspective, the landscape is very much fragmented. Because now as a device manufacturer, also an app developer, if I have a nice idea of an application, I need to do it for example, the Mini Connect. I need to do it for AppLink. I need to do it for Entune. I need to do it for Pioneer App Radio. Each of them are more or less a bit maybe the same, but they're different. So I need to actually redesign a lot of my application. And also from a device manufacturer, if I would like to support this, I would like to provide application developer support for those solutions, I need to actually do a lot of work in order to facilitate this. So there's a heavy fragmented area which is important to serve, but there is definitely up for doing some changes. The other problem dealing from a mobile device manufacturer with automotive is a completely different life cycles. Automotive it's a very sort of, I would call it conservative, so it's long production, long development time, and and very rare, if at all, updates. So it takes about 3 to 4 years to develop a head unit infotainment system. So you really do it in big cycles. On the phone side, the mobile side, you have much more rapid development. So it takes about a year up to 1.5 years to actually do a real complete new phone development. And you have some rapid updates after that. So more or less, whenever you ship a device, 2 or 3 months later, you get the first software update for this. I'm providing bug fixes, but particularly also providing enhancement to the platform. And if you then look on the application side, it's actually much more faster than. It's really that you get if you have those hot applications, you get updates on a weekly, monthly basis, adding new features, doing bug fixes, and also just putting out new applications. And if you like now to bring this all together as an automotive manufacturer, say, what are the applications I need to pick to bring into my infotainment system? What are the devices I need to work with to get them in, enable them working with my infotainment system? It becomes a guessing game. So if you look back, if I would be an automotive manufacturer a year ago, and I needed to decide what social application to put in, so if I wanted to bring it to the market today, I started development of that infotainment system about 4 years ago, and I might have picked MySpace rather than Facebook to put in. So it's very difficult to predict which of those applications are getting successful at the end. And consumer are switching back and forth. So it's hard to predict that they don't stay that much with one service, which is different on the automotive side. So the time a car stays with a customer is pretty long. You have invested it. If you bought the car, you actually have it much longer than if you just have a lease term. On the phone side, it's more or less regulated by how long the contract is. If you have a 2 years contract, you get a new phone after 2 years. And a lot of us actually get a phone much. Just if there is a new hot device out, you try to get it. And I mentioned on the application side, you jump from one application to the other. Some of the application you stay longer with because you like them, but otherwise you try out. You recognize, oh, my friend is using a cool application, I would like to have it. I install it, I use it for a certain time, and then use something else. So that's a really challenge to bring those pieces together. The automotive side, long development cycles, and things stay with the customer very long. And on the app side, on the device side, you're jumping back and forth, you have more rapid development. So the challenge is how to deal with this. So what's the best approach? And I have to say, so I stole some slides from, I need to reference to Mika, so I mentioned it. So what would be, getting the back, so what would be if IKEA would design a car? Completely strange question. Of course, the obvious one is you get individual parts, right? You get them in and they're stored somewhere on a shelf. You open the box, and you see a lot of parts in it. But the cool thing about this idea is actually, in order to put it together, you only need one tool. And it comes, typically, if you go to IKEA, you get it with a tool. You don't need to buy don't buy the tool and then try to get it. It's a one simple and universal tool. You can use it for all the parts to connect. And that's what we would like to do with MirrorLink, to provide this one simple universal tool to connect the phone with the car, with the infotainment system. So we don't want to have one tool for this device. So if you buy a bed, you use this tool. If you get a shelf, you have another tool. They all look different. You need actually to learn how to use the tool. We don't want to do this. This one thing, simple, universal tool. As an app developer, you only need to learn this one tool. As a consumer, there is one simple way to connect the phone to the car. This is what we would like to achieve with MirrorLink. So how it works. So as mentioned that I'm sharing the technical workgroup responsible for the technology development. So I need to do something on the technology side. But starting with the big picture, and Gauthier has been addressing a couple of the main parts already. The important part is that MirrorLink applications, MirrorLink services stays on the phone. So as an app developer, you design and you develop your application by using what the phone SDKs, the phone manufacturers offer you as app development support. So you know how to use it because those app developers, you have been doing it for years already. So you know the platform, you know the tools, you can stay with those. You don't need to learn some strange embedded language, embedded tools for the head unit. You stay with what you know. MirrorLink takes care of remoting the user experience, the user interface from the phone to the head unit. So in use, you're not, as a driver, as a user, you're using your phone's application, but you're not interacting by touching the phone, looking at the phone, you're touching The steering wheel, you're touching a rotary knob, you're touching steering wheel control, and you're looking at the big screen on the middle console, or wherever the screen is placed. On the audio side, you don't need to try to listen to what the speaker output on the phone is. You get the audio out of the entertainment system. If you need to speak back for example, in a phone call, you don't need to hold the phone again. You can use embedded microphones provided from the car manufacturer. And they know better how to place the microphones. They know better how to do noise cancellation than we can do on the phone side. So that's the main part, is one way to bring down driver distraction is just make it very easy for the user to not touch the phone, to not look at the phone, because it's much easier and much more convenient actually to use things which are available in the car. So now from a connectivity perspective, because the first thing what you need to do as a user, you need to somehow connect your smartphone to your car. We don't want to invent anything from a connectivity solution. We want to take what's available, because we don't want to force car manufacturers to invest in a new connectivity, and also we don't want the device manufacturer to do the same. So we just go what's there, and what's there is USB. It's universal. Every smartphone has USB. Most of the cars have already USB. We know that from the usability perspective, handling with wired might be a bit strange, so therefore, of course, it works with Wi-Fi as well. We have Bluetooth support mainly for the audio part, so if your car is equipped with Bluetooth hands-free profile or with HTTP, you can use it. Everything else is based on IP technology, so that's why I put the IETF logo in it. And the main reason for this is, again, we don't want to invent. A lot of the things we're using in MirrorLink is actually already invented 15, 20, 25 years back. And we just said, okay, we use it because it's stable, it's known, and you have many of those stacks, many of those protocols, they're already there. They're most probably already on your platform. So the first thing is, from a user's perspective, you connect, and now you need to have some sort of discovery. So the phone or the head unit infotainment system need to discover, I'm connected to a MirrorLink phone. So there are simple questions you need to say. Are you alive? Yes, I'm alive. Who are you? So you exchange some basic information that I'm a MirrorLink-enabled device, and I'm able to provide you this. And then the head unit and the infotainment system can connect to this. And the first thing what the phone is providing is a list of applications. So the phone tells the head unit, I have a music application, or maybe I have 2 or 3 music applications. I have a drive application, I have a social networking application, I have a calendar application. All that is provided to the head unit. Not the application, only the information about those applications which are available. So we, for example, provide icons. And the icons then can be rendered on the head unit screen. The interesting thing about this is that as a user, you know those icons because you interact with your phone all the time. So you're familiar with those icons. And as soon as those icons pop up on your head unit screen, you know what those apps are. So you don't need to learn anything new in that regard. And that, again, helps bringing down driver distraction, which is a big thing in automotive and which we always need to take care of. And of course, the ultimate goal as a user is, of course, we would like to provide those applications for use while driving. So meaning we provide the mechanism to launch an application, or to terminate the application if you don't use it anymore. So that the user, for example, can click on one of those icons, and the click basically initiates to the phone, launch that application, bring it to the foreground, so that I can grab the user interface. All that, we haven't invented it in that regard. It's based on UPnP, so a well-established stack, and we only develop and specify those relevant services which, based on UPnP, which provide that sort of capability. So once you launch an application, it's running on the phone. The thing what's missing is you need to grab the user interface. As mentioned, you don't want to force the driver to look at the device, so you basically would like to remote the user interface into the head unit. So actually 3 elements in that. You need to grab the display part, the content part. That's done. Technologies like VNC are out there for years. which are well established to grab the user interface. VNC takes care also on the eventing part, so you can touch the head unit screen, you get pointer events back. You may have a knob where you can push, you can rotate, you can shift. You grab this as an event, you push it back to the phone, and the phone's application acts on that. And then the last thing is the audio part. So you can able to stream audio either via Bluetooth or via the regular RTP protocols, so based on IP technology. You stream it to the audio entertainment system, to the speaker, and you have also the ability to input audio and stream back to the phone. Well-established technology, nothing new. We extend it a bit where needed, but otherwise we stick to which is available. And now actually the most interesting part from an app developer perspective is that the car is not only providing you sort of mobility, it also provides you a lot of data. It's actually a very rich sensor platform. And as an app developer, you may see very, very nice opportunities for providing your services if you would have access to this. So MirrorLink, as part of MirrorLink, we provide a mechanism to have access to data services which are available on the head unit side. A data service can be, for example, a location service. So the embedded GPS receiver on the car side is much more accurate than the one on the phone side. And if you're losing GPS, the head unit can use the tire sensor to actually extrapolate your position by just using those sensors rather than using the GPS sensor. So much more accurate in location information. And that data could, of course, be of huge value for the phone. And that is one of the data services we have already specified. You can think of all the other data services and data values which are available. Engine diagnostic data, windshield wiper status, light data, and whatever. A lot of data, and a couple of that, and a lot of that is actually of interest for app developers to utilize. So that's why I have that guy holding the left. So it's that way see where innovation will come in. Once you have that access to that data, you will start using it. You will start meshing it up with data locally on the phone and with data available remotely from the cloud. One of the most important differences using an application within the car while driving and an application if you had on a regular smartphone is that you're operating it in a regulated environment. So you're using an application while you're driving with 60 miles per hour or more. So you need to be sure that the user interface, as Gauthier pointed out, is safe for use while driving at that speed. So meaning it's distraction-free, it's distractionless, so it's safe to use while driving, and you're, for example, not showing a video while you're on the road or playing any game. So you would like to ensure that whatever shows up on the head unit screen provided from the phone is safe to use while driving. This requires a sort of trust relationship. The head unit needs to trust the device to provide that only certified, approved content. One of the big things what MirrorLink is specifying is an establishment of that trust relationship. And we are using a certification mechanism for this. So we have a central certification authority, a central CA, which is governed and maintained by the CCC, and which basically does two things. It certifies MirrorLink device manufacturers by providing signed manufacturer certificates, which they can issue certificates to the devices. And at the same time, they also provide the sort of public key component of that certificate to the head unit. And what the head unit can do, it can then start matching this. So the head unit will receive the device certificate and can match, okay, this is a valid certificate. I'm communicating, and I'm connected with a certified device. I can trust that device to provide only relevant, authorized, certified content. And this is it's a sort of small technical element what we have put in, but from a sort of trust relationship perspective, it's a very important topic and a very important part of the overall puzzle. So in that regard, MirrorLink is much more than just sort of a screen replication technology. It's a lot more. It's about the trust relationship. We have the certification process on, so a lot of different components that actually make it work. And to make it work, we have an interoperability program, a certification program for doing device certification, which is basically in product certification. So we certified products, head unit products, as well as a phone product. And Gauthier has listed how many of those products we have already certified. Certification is not done by, or the testing is not done by ourselves. We have up to 10 authorized testers who can do the certification. And we have a neutral certification body, which is receiving the test results and then issuing the certifications. We do two types of certification testing. So we do conformance testing, so meaning protocol compliance testing, and we also do real interoperability testing, so meaning connecting real MirrorLink server devices with real MirrorLink client devices. Because at the end, we see it as a consumer promise. So if you as a consumer, you buy a MirrorLink certified server, a phone, and a MirrorLink certified head unit, and you then download and install a MirrorLink certified application, they have to work. No matter what, they have to work. That's a promise we would like to give out with that MirrorLink certification process. So now coming back to why actually that MirrorLink is that important for device manufacturer and for the mobile industry as the device manufacturer perspective. I think the first and utmost advantage is it brings standardization, brings simplification, simplification into a fragmented market. So rather than having to deal with all the different proprietary solutions, it offers a way to have a single universal solution. So as soon as you have the single universal solution, it gives you scale, it gives you cost reduction, and also allows you to emphasize on what is actually important. So provide a safety user interface, provide the right services. That's the focus it gives you then. And you don't need to have the investment into supporting the fragmentation. The important thing is that the connectivity part, so how to connect those two things, that's not the differentiator. The differentiator is how to use it, what you put on top of that. And that what allows us as a device maker, also as a service provider, to really focus on that part, to provide the right services and to provide the right application to our customer while they're on the road. Particularly on looking into how to best integrate it to the car, how the user interface is to make it more simpler, and also to see what the new services are. From a consumer perspective, it gives a promise that you have access to more services than you have today. So today, as mentioned, you have entertainment, like in the area of music, internet radio, and you have navigation. But MirrorLink gives you the possibility to expand this to all the different kinds of services and applications you have on your device. And of course, as an app developer, now you have the possibility to actually reach out to this domain, which has been closed so far. So as an app developer, it's very difficult to actually develop for embedded systems, embedded infotainment systems. So now using MirrorLink, it's much easier because you just use the phone as a development platform. And it also from a device manufacturer actually fits pretty nicely. Because at the end we see that the phone is in a way, it's a very personal device, it's a connected device, and it's connected to different domains. And the car domain from a device manufacturer perspective is just one domain. We need to deal with the other domains as well. So meaning the home domain, sort of the by body domain, and also the backend, the cloud domain. And MirrorLink gives you this one way, a universal solution towards the car, so we don't need to worry about all the different things. And because we have to worry about all the other things as well. So in that regard, it fits pretty nicely also into the overall picture of a smartphone being the facilitator of facilitating a connected life. With that, I think I used all my time, and would like to start and opening up the discussion on the panel. So we have actually 4 panelists. I forgot Gauthier to put on. I think he just took a shave. So we'd like to start on the outside end there. So it's Alfred Tom from General Motors, heading at the moment the ecosystem work group. Joel Zuckerman from NPR, National Public Radio. So I guess he maybe to provide some particular perspective from an app developer perspective, a content provider perspective. We have Robert Warburg from General Motors. He has been he's heading at the user experience work group within CCC, and Gauthier. Are there any, so we have about, I guess, about 12 minutes for question and answers. So are there any particular questions from the audience and topics from the audience we should like to address here on the panel? Because otherwise, I at least start with the sort of introduction question. So, if you would be the app developer, so where do you see the main benefit of having MirrorLink and MirrorLink-enabled devices on hand?
So I'll start. So for 40 years, a driver has been able to sit in a car and press a button and listen to National Public Radio. And over the last 5 years, NPR has had to become a technology company competing with technology startups in Silicon Valley and making sure that relationship that we have with the listener is still is maintained, right? And so we're technology agnostic. We need to be anywhere that there are potential listeners. But it's very difficult to be able to provide the same kind of functionality, the same kind of content in new ways when I have a finite amount of resources and I'm deciding, do I build an application for Roku, for mobile, for entertainment consoles in the living room, and I have the same developers and designers that are working on those as working on an application for the car space. So in terms of finite resources and having to have functionality and applications available everywhere, some amount of standardization is really important.
Any more thoughts from the panel?
Yeah, I think what people don't realize is that the time consumers spend, at least in the United States, in the car is about the same amount of time they spend, surfing the web. It's on the order of magnitude of 2 or 3 hours. So if you think about all the money that people are making on the web, and you apply that to cars, it's a pretty big opportunity. So, before I've been at GM for almost 5 years now. Before, when people used to come to me and say, I have this great app for the car, I'd say, well, it's going to take about 6 months to talk to people in Detroit, and it's going to take another 6 months to integrate. Then you have to wait for the head unit to come out. Now I just say, develop for MirrorLink or develop for these other open app platforms, and it makes my life a lot easier. It makes the developers' life a lot easier, and I think we're going to finally see some innovation in the space and realize that potential and have consumers, enjoy the time they spend in the car, despite how much time they're spending in there.
Any question from the audience? I guess we have a microphone.
What do you see as the major competitors to MirrorLink?
Well, there's a slide with a bunch of different competitors, so that, you could consider those main competitors. You could also consider autonomous driving to be a competitor when that finally comes online, because if the car drives for you, then you don't need driver workload distraction issues. So even anything between proprietary solutions to autonomous driving is a competitor.
I'm actually going to challenge my colleague and mention that maybe they aren't as much competitors so much as complements. Excuse me. MirrorLink offers something that's particularly unique to the user. That is this notion where the application actually gets to represent its own brand through user experience. I think that's something that's just different. It's a notion where it's turning a combination smartphone and vehicle into an open application environment. It's opening a new marketplace as opposed to converging on structure, templates, and I want to say redundancy, but similarity, where there are sort of categories of apps, and from those categories, one might have to select your favorite one or two. I think that from a productization standpoint and from how it interacts with a vehicle and looks in a vehicle, actually really helps. I think it also then really does sort of provide a more continuous experience of the software itself, where it's one software in the car or in the rest of your life, as opposed to your car app versus your home app. And so I guess while there are other solutions to bring apps to cars, it's more accommodating the app to the car as opposed accommodating the app to driving.
At least I think at the moment, what I see at least, that a lot of people bringing smartphone apps to the car is just putting the phone into the dashboard, into the windshield. And it is what would people recognize that, yeah, phone user interfaces are not designed for this. So that it's harder to reach, you need to reach out. If you put it to the windshield, at least in some of the cars, you actually really lean forward to this. So that I think there is a way to bring those things to the car, but it's not a convenient one. And it's definitely not a one which is suitable for the in-car use. And it's of course not integrated. I think that was the result, so that it's not integrated to some of the elements the car is able to provide you. Microphone is coming.
I have a couple of questions. One is, how does standardization get paid for? And what are some of the barriers you see, getting that in place, and how are you addressing those?
Can you repeat the first part of the question, please?
Standardizing the interfaces, who's going to pay for that? How does that get paid for? If you look at sort of the ecosystem, how does it get paid for? And then two, what are some of the barriers to standardization, and how are you dealing with them?
I guess I think it's one from how to get paid is I think if you look at the alternative would be, as from a device manufacturer perspective, we need to deal with all the different OEM solutions, and we need to develop for those, and we need to test those. And now if you compare the result of standardization, which is this single interface, there is some return of investment. Of course, we need to invest in creating that standard, but the return of that investment in the long run is much bigger than we invested in the beginning. So there's a simplification in standardization, which is really beneficial, particularly with regard to the testing and the IOP.
But to be clear, that's not putting handcuffs on app developers, right? I mean, the standardization is in the framework itself, not necessarily within each individual app. And for me, it's as much a defensive posture as anything else, right? 40% of listening to public radio happens in the car, and if I'm not at a place, and I can't afford, again, to put those resources to every single car company to do a handmade unicorn for each individual one. We can do a few, sure, but if I'm able to do one that can go across the board for most of them, talk about paying for itself. It's a much cheaper solution than having to develop for each individual one.
Just a simple question. I just want to know, to realize the connection between the smartphone and the car device, what does the smartphone need to do? Just simply download an app, then can support the MirrorLink, or they need to do something in the OS? Thank you.
So they're basically two components. So the one is the MirrorLink stack as such, which is at the moment for some of the existing products is a downloadable app, which requires some enablers from the platform. So, for example, we are using a mechanism to copy the frame buffer, so you need to have some good access to the frame buffer. So, but at the moment, the thing what's out in the market, you download an application, and you may have a firmware upgrade. But as a consumer at the end, what you worry about, what you consider is to download an app. So if you have an application which, for example, in an application from NPR, which gives you access to that content, this is you just go to any regular app store you have. As a user looking for MirrorLink enabled apps, you go to your place where where you find your applications. The MirrorLink stack going forward will be just provided as part of the platform. So as a user, you may not want to, you need to install anything. At the moment, yes, the system which is out there is installable applications. You go to an app store and download that MirrorLink app, and then you can download other apps as well. But as a user in the long run, you only look for applications. You don't need to worry about the MirrorLink stack. That's something which runs in the background.
I want to know how you design for it, because if you say it's independent of your programming language and independent of the device it's running on, normally you design interfaces for, to tailor an amount of screen sizes, but not all screen proportions and everything. So how will it display on all the cars' screens?
So the one element what we have in MirrorLink is that we have APIs which provides information on how the car site looks like, so that application can start adapting to the different to the screen sizes of the head unit. So we assume some sort of minimum screen size. We don't expect to have a very small display. So we expect some medium or high-end sizes screen. That information is provided to the application. It knows the resolution. It knows the physical dimension. It knows the distance from the screen to the driver, so that the application can be optimized for the specific configuration.
But who optimizes, the app developer?
So I can add a little more to that. So you're right that if you have an Android app, you're going to have an Android APIs to access MirrorLink. If you have a Windows app, you're going to have to use the Windows 8 APIs. Eventually, we want to get to the point where there might be user interface elements or widgets that you can use in an app that automatically adapt for you. For example, the operating system understands what type of screen you're running on, the distance and things like that, and then you just lay out the widget in the graphical user, your WYSIWYG editor, and that widget will just automatically adapt. So that's one possibility. In the meantime, if the operating system doesn't offer that kind of capability, you might have to actually take input from the operating system and then adapt your user interface accordingly. Like if you develop an HTML5, use @media queries. If you use some other a more native environment, you can adjust that way.
So to establish phone mode and car mode, that will be also integrated in the Android API and the Windows API, etc. For now?
Well, it depends on the platform. But there will be messaging, say which mode you're in.
Yeah. There was some other question.
Yeah, just curious, how many app developers are in the audience? Okay, why are you guys here? Just curious. I mean, what is your interest in this? And are you?
Yeah, from our side, it's pretty much the same. We've been looking at the different app environments which are being set up, Ford, Renault, and so on and so on. But since it's completely fragmented, we couldn't afford the resources to develop for all of that. We're a small organization, we're a startup with a specific product, which actually finds its place the best in a car. It's regarding parking.
Yeah.
So it makes no sense to start developing for all of that. And we're looking forward to have it introduced.
Okay. And And then curious for you, are you looking to adapt existing applications for the car environment, or are you looking to build a whole new app directly for the car environment?
Well, since it's the first time I see this presentation right now, the question raises if we indeed make a second app, or if we adapt the current one. Actually, adapting the current one wouldn't be that much of a bad idea, since the usage will be mostly in the car, and we should also take your notion of helping people to drive safely into regard. So, I think maybe going to one app would be the best.
So then I have a sort of one question I've done to the panel is so besides being able to provide to remote the user interface to allow the control of the application from the car environment, how important you see that the car is providing data and gives access to some of the configurations of the car. Read out those values for the app to present to do something with it. How important do you see this as being part of that ecosystem?
Well, I think there's a couple of different ways. I mean, you can imagine a whole range of possibilities. Everything from just the simple ability to use voice commands in a way that is much easier. From that to starting to learn about behavior of the driver. If I can see a world in which if I know that you've got a 25-minute commute every single day, that we can feed you the best 25 minutes of content that will help you start your day. That will be able to provide more relevant traffic to the route that you take, and not just this general world of traffic, 95% of which is irrelevant to the commute that you have. So starting to provide some bits of data about what you do that you're willing to share that provides benefits. I mean, we look at the folks like Netflix and Amazon and others and think, all right, if you're able to provide real value to the customer, they're willing to give up a little bit of information. And I think if you're able to find how you can help solve a problem for a driver and a listener, I think that will go a long way towards making a better experience and fostering more use.
Yeah, that's why I wanted to ask the question. If you guys are developing your own apps directly for the car, what type of data do you need? We could sit there and guess, but it's better to have that feedback from the developer.
So if you would have a wish, so if you're interested in data, so what sort of data you would be interested in? Anything would say that would be beneficial for my app. Any wish? Mm-hmm. Mm-hmm.
Yeah, from our side, like you say, the exact location, also the destination might be interesting. And I think we should definitely work it out. I think you guys know better what you have also from data you can share, or what you work already with for your own applications.
That's actually a very fair question. And at the same time, we're excited to be hearing what you actually want to have, because we have a large set of potential candidates. What always becomes a challenge for us in terms of engineering it really is about prioritization. And so much so that don't be surprised if in the near future here you are contacted again about this same question. We actually would very much value requests, recommendations. But a part of that challenge also comes back to normalizing the data. It goes back to the sensor, the fuel gauge, the fuel level sensor on a Volkswagen and the fuel level sensor on a Chevrolet may not return the exact same data information. So how do we neutralize that brand dependency into something that an app can scale across those? So that in the long run becomes a technical challenge for the consortium, which I think we can solve. But in the meantime, we just need to make sure that we're putting our resources, our time and effort into what will yield the most vibrant ecosystem. And that's where we're looking to you to give us some guidance. Or, if you're available, join in. You know, we're all also, our membership is open to all industries, all spaces, and we would love to have, to further diversify our participant spectrum. So.
Okay. Any more questions and comments? Feedback? I think. Then, thank you. Oh, no, sorry for that.
This is just a theoretical one, but at one point I worked with some people, Google and Ericsson and Vodafone. They created this .mobi consortium so they could re-render screens or internet sites to fit the mobile screen at the time. And the whole idea was, you know, they'd collect all this data and they'd know which phone it was going to be used on, and it would then render the site to that particular phone. And they went through a full top-level domain registry, and now there's a .mobi that you can register for. But they were trying to solve the same problems sort of you're having now, which is regular content now having to go in a different environment. Never really took off because the industry went a different way. And do you see that potentially happening here, where the solutions come outside of, you know, re-rendering device screens for the car?
I think there is a challenge in that regard. If there is a sort of fragmentation on the screen sizes and the different configuration, I think what you see is that with the advance of display technologies, actually the panel sizes, there is a fragmentation, but actually the fragmentation is not huge. So there is a sort of traditional resolution which is mostly used. So what we expect in that regard is that there will be a couple of app developers which just develop for the sort of worst case, so for the lowest resolution, so you can be sure that it's shown up there. If the resolution is high, just scales up. And scaling is nothing what the app developer needs to take care of. That's what the MirrorLink takes. MirrorLink takes care of the scaling and the adjusting resolutions with respect to scaling. App developers don't need to worry about that. They only would need to worry about that, is my font size big enough if it's displayed on a wide VGA resolution screen or on a high density 720p display. That's what app developers need to take care of, but they don't need to worry about the kind of scaling aspect. So that's what the MirrorLink as such takes care of. At the moment, from a CCC perspective, we have standardized those pixel-based interfaces. What we are looking into is expanding, going beyond that. So using like web applications and web technology to use, okay, if we would have HTML5, how this can be beneficial in this. So that's something what we look into this as well and try to standardize as well.
I would also say that this is an evolution. I mean, I think, you know, the problem that you describe is not unique to this environment. You know, we have a lovely Android app, and all of a sudden Amazon comes out with the Kindle Fire, and now all of a sudden my lovely Android app looks ridiculous in a different form factor. So I think that there are certain, I think, assumptions we can make and bets that we can make that that behavior in the car is so different because of the safety aspect of it and the importance that you have to place on gestures that are not distracting or voice-activated commands. But I mean, you're right that 2 years from now, 18 months from now, something's going to be different, and we're going to have to continue to evolve. It's not going to stay the same, but try to anticipate best we can given the constraints that we know today.
And the nice thing is, as the application is stored on the phone, for the app developer to, if they recognize, oh, there's a new car with a different display resolution, to just create a different variant and make it available for users to download. And they don't need to wait for the next head unit release to actually get it to the customer. So that's the nice thing. We're using the phone now, and we can use all the infrastructure for distributing applications, distributing new version of that application. to that. So that at least one advantage you get with the MirrorLink system by able to utilize the phone platform in this aspect.
And, you know, I think you alluded to another question, which is, you know, how can we predict what's going to happen in the future? Is the industry going to go in a different direction? And I think that you look at the membership, right, and the people that are involved with this consortium, you know, it's a pretty big swath of the industry. That being said, there are a couple of companies out there that could, you know, blindside anybody in this industry. And if anything is going to come about that's unexpected, it's probably going to come from one of those companies. So, and everybody's fully aware of that.
Okay. I guess we have reached our time. So thank you very much for your attention and the questions, and thanks a lot for the panel. And that concludes the last session of today. Thank you.